Okay, and in the last section, I want to talk about a little bit about reproducible research. I want to tell you why we want to do reproducible research and how to do that. Okay. First, a definition of reproducible research. Actually, there's a web page called reproducibleresearch.net. And this defines reproducible research as a paper that describes your work in all relevant details, some source code to reproduce all the results of your paper, and also the data that is required to reproduce the results. So it doesn't help you to have an open source algorithm when the data is not accessible. And finally, and this is also very important, you need to provide detailed instructions on how to apply the source code on the data to replicate the exact results of the paper. And possibly just as a copy and paste command line to make it very easy for the people to do that. Okay, Van der Waal in 2009 defined 6 levels of reproducibility. And most of the work is, unfortunately, level 0. It's completely irreproducible. Or level 1 cannot seem to reproduce because there are some details missing, or the data set is not accessible, as I said. Then there is level 2 is reproducible with extreme effort, like requiring 1 month to implement something that is given in a paper. Level 3 is reproducible with considerable effort, around a week. Number 4 is easily reproducible, which means 15 minutes. I mean, 15 minutes to set up, not to run the experiment. That might take more, but 15 minutes to set up. But it requires proprietary software, for example, MATLAB. And level 5 reproducibility is easily reproducible, only free software, like Python instead of MATLAB. So why would you want to provide reproducible research? I mean, writing a paper, getting that out, getting that done, fine. And when you want to provide the source code with that, it requires a considerable amount of time to do that. But there was another research from Van der Waal in 2012 that showed that this providing source code and just in any way, so reproducibility level greater or equal to 2, so just some kind of source code, will lower the entrance barrier to your publication. And he made a test that he showed that only 10% of the papers in the transaction of image processing provided some source code. So if you provide source code, you stand out the current trends. And it is more valuable. So 13 of the 15 most cited PAMI or TIP papers provided source code. And by providing source code, you can, at an average, multiply the number of citations of your paper by a factor of 7. So I hope that this is giving some initiative to try at least to provide reproducible research. And also, when you work in a team, it is very nice for people that join the team to start from the state of the art. They don't have to implement all the things that everyone has implemented on themselves, but they start from the state of the art, and they start to work fast. And it's also very easy to collaborate with external partners. So when you want to share code between 2 universities, when you have the same framework, then it's easy. And you create something durable. So it's not that you hack together some script and in 2 months you can't even read it yourself anymore. No, you want to have something that can be used in years if it's still good enough then. And you avoid redoing things, obviously. But this requires that you and your team members improve the source code every time. So you have a bug tracking system, and you fix some bugs, you rerun experiments, and so on. You test your source code, you document it, and you keep it operational. And documenting it is a very important point, because software without documentation is useless. And as I said, you do that for the benefit of all the team members. Okay. So we have defined requirements for reproducible research in a paper that we published this year, which are 4 basic points. First of all, it must be repeatable. So when you rerun the experiments yourself, you obtain exactly the same results. And in the Bob Bio framework, we have done that with the configuration file, because the configuration file contains the exact configuration of your algorithm, so you can rerun it and you will get the exact same result. It is shareable, so you have the possibility to share the data and the source code. And this is most easy by some open source code and data that is freely available, or which you provide freely available to others. The third requirement is to be extensible. So it should be easy for other people to download your code and tweak just a little bit here and there and implement a little functionality here. And it should be able still to work. And we tried to do that in the biometric framework. I hope that I managed to do that well. And the fourth requirement is to be stable, which means that you guarantee the repeatability through time, which is very difficult, as I have explained today, because there might be some external library that change, and at a certain point your results change because you get different input from these libraries. So, but how you can do that is you create a Conda environment file, and you pinpoint the versions of all the libraries that you use, and then you are sure that at least when you run on the same machine or on a similar machine, that you get the same output. And most of that is, I hope, fulfilled with Bob and Bob Bio. Okay, now the steps to publish your research, or to open source your research, is that you already design your experiment reproducible. That means first, you avoid proprietary software. Use only free libraries. Use a free language, an accessible language like Python. Not necessarily, you can also do that in C++, but Python has been, is very research friendly, let's say. And you should keep things apart. When you run one experiment, you would want to set up one environment and build one Conda package out of that. Don't mix up things, because then it gets messy. And you should keep track of the required software, for example, in the environment file, and pinpointing the versions and so on. The second point is you should use a version control system for your code. Like in SVN or Git, or there are older ones, it doesn't matter. And it is also important that when you submit a paper, you should add a tag to your Git, to your repository that says, I have submitted this version of the source code. Because only then it's actually reproducible and you know exactly what you have published. And another positive point about version control systems is that usually they have an issue tracker, and it's easier to work together with people using a version control system. A third point, and this is actually something that people often don't do. So the first 2 points are okay. The third point, implementing unit tests, most of the people don't. because it requires time, and it requires to think about how to implement a unit test, and it requires also the framework to do that. So, but I think it's very important because every change in any part of the software might change the results completely. And the fourth point is provide documentation. Again, without documentation, source code is useless. And the documentation should include installation instructions so that everyone can easily install your software. And it should contain command lines to rerun the experiments, like copy and paste. And finally, if you want, if it's a Python package, you can version, package, and publish that, for example, on the Python package index. But this is an optional step. If you have it in the Git repository and can check out the Git, that's also sufficient. OK, and finally, I'm coming back to the Biometric Evaluation and Testing Framework, which is a web-based platform to evaluate biometric algorithms. And it provides open source toolchains and algorithms that you can combine. And as you can see here, it's not the highest quality, but you have like this visual toolchain which you can actually connect these blocks. And when you click on one of these blocks, you will get to some, in this case, Python code, and you can actually implement that block. And one of the nice things about this Beat platform is that you can get an attestation of your result. So you can make sure and you can add this link into your paper so that anyone can click on this link and will be located or relocated to the source code and to the implementation of what you did. And they can be sure that it's correct. OK, I think that's from my side. I hope I have shown a way to escape the visual circle today. And if you have more questions, I'm here.